Hey everyone, it's Mr. Canfield, and we have our logs quiz next time, so I thought that I'd post my review on the internet for you. Okay, so I'm just going to go through the problems, and feel free to message me on Schoology if there are any other issues. So, let's see, if we look at this first one, it says condense to a single log. So if we're trying to condense this, the first thing we want to do is we want to look and see if there are any numbers out front. So like I see that 2 out front, I can bring that 2 inside as an exponent. So I could rewrite this as log y plus log 5 squared. And 5 squared is just 25, so I could just write 25 instead. And then that plus means that I can take those 2 logs and I can multiply the insides. So you could say y times 25, or just write log of 25y. And yes, absolutely, if you left it as log 5 squared and y, I'd rather you write 25, but 5 squared's true, so that's fine. So if we look at this one, we're starting here and we're working our way backwards. So if we think about the last thing we did here was we combined the logs, the first thing we're going to do here is we're going to separate the logs. And so we see that minus sign. That minus means subtract. So I can write this as 2 logs with a subtract between them. So I'll write the first one, I'll write the second one, and then, so looks like we brought an exponent inside, so are there any exponents to bring outside? Well, I can bring the 2 outside here, and also with this one, remember that log square root of m, that's the same as log m to the 1/2. They're synonyms, so I could bring the 1/2 out front, and so I could say 1/2 log m minus 2 log n. All right, so we might get a couple more like that on the quiz, but that's the big idea. Let's see, solve and show your work. Answers must be exact. Ooh. So that means that our answers are going to be nice. So if I were to do this one, we'd get, well, the exponent's already by itself, so we can write log 1/4 8 is equal to x. And so if I go to my calculator, let's see if I can do this. So if I go to my calculator, I can say, remember we've got that alpha, boom, log base 1/4 8, I get negative 1.5. So I can say x is equal to negative 1.5. There's certainly a way to do this without the calculator, but this is what I'm most concerned about is that you're able to do that. And just remember, if you don't have one of these at home, you can Google, you can say log and then type space and do 1/4 and then do space 8, and it should bring you to a site or something that'll be able to help you with that. So if we look at number 4, there's a plus between the 2 logs. So before we can rewrite, we need to make it look like a single log. So I'll use the plus between the 2 logs to multiply the insides. If I multiply the insides, x times 2, that's 2x. And now I can rewrite. So I'll write this as 4 to the 3 is equal to 2x. And 4 to the 3, that's just a number. So I can say 4 to the 3, I got 64. So 64 is equal to 2x. And we're just going to have to divide both sides by 2, and we'll be done. 64 divided by 2 gets to be 32. So x is equal to 32. So if we look over at this one, whoa, that's a big mess. I wonder, can I just type in literally what I see? Oh shoot, there we go, it's just 3. So that's 2x is equal to 3. And yes, there is a way to get that without the calculator, but I'm not going to stress anybody out and go through that right now. So now I can divide both sides by 2 and get x is equal to 3/2, which is also the same as 1.5. So we got that one. That one. All right, let's keep going. All right, I said in class, don't worry about this one. But I did say I would go through it in the video. So that 10 means times, so I can write this as log 10x plus 60, remember, because 10 times that you have to distribute, is equal to log of 30x. And so it's log equals log. That means the insides are really all we need to care about. They need to equal each other. So I can say 10x plus 60 is equal to 30x. So if I'm going to try to solve this, I'm going to try to isolate x. Well, I have x on both sides. Let me move that by using inverse operations. So we get 60 is equal to 20x. Divide both sides by 20. I get x is equal to 3. Again, don't worry about this question. I guarantee you do not need to know how to do that for the quiz test. Quiz test. All right. Next one. 5 to the x minus 2 equals 25. Well, we can rewrite that as a logarithm, because remember, the whole exponent thing is by itself. So if I rewrite that, I'll get log base 5 of 25 is equal to x minus 2. If you don't know how to do that, remember, we just, oops, bam, bam, there we go. So we get 2 there. So I get 2 is equal to x minus 2. So I can just add 2 to both sides and get x equals 4. So now if we go over to this one, should have told you not to worry about this one too, but I'm going to go through it. So log base 2 of, if I multiply x by both of these, we're going to get x squared plus x. So the thing is, we have not done a lot of x squared problems recently. I'm not expecting you to do this on the quiz. If I rewrite, I'm going to get 2 to the 1, which is just 2, is equal to x squared plus x. And so the way we solved something like this is we made it equal 0. And then we would factor. So again, this, don't sweat this. So 0 is equal to x plus 2 times x minus 1. We get x is equal to negative 2 or 1. And secretly, remember that negatives don't work in logs. So this is where I need to sidebar and say, look, this is what I used to use in my honors classes. We haven't gone into all of this stuff because not all the stuff we do is honors. So don't sweat all the stuff that just happened there. The main thing that I care about you understanding for my class is that we condensed, we rewrote, and then we were trying to solve from there. So that's really the key. All right, let's see. Number 9, it says log base x of 27 plus log base x of 1 is equal to 3. So I can combine these, and I can say log base x of 27 times 1, that's just 27, is equal to 3. And then I can say rewrite, and write x to the 3 is equal to 27. And so if we want to find out what that is, I can cube root both sides and get x is equal to 3. Oh, this looks so weird. Let's try it. It says 100 to the x, so log base 100 of the square root of 10 is equal to x. So I can use log base. Oh, okay. And then I can turn it into a fraction if I want, and I want, so I got 1/4. Okay, so I forgot to circle that answer. Such a big deal. All right, so now I don't know. So I was on the front and then I turned the page. Sorry, I paused to let my AP workshop class know that they're doing great with how quiet they are. Okay, we see this. Well, we want to get the e to the x by itself, so I'll subtract the 1 from both sides, and I'll get e to the x is equal to 11. And then remember that when we rewrite this, if I write log base e of 11, that is true. But there's an abbreviation for log base e. I could write ln 11. Both of those will get the same thing in the calculator, but so equals x, right? Equals x. So if I go in here and I say ln 11 I get that. And if I go in here and did the same thing with that button, log base E, oops, shouldn't use that one though, I should use the, yeah, log base E of 11, bleh. It's the same bit. So it says 2 decimal places, so 2.39 would round up to 40. Now this one, it says ln x minus ln 3. Remember that means to take the insides and divide them. So I'd say ln x over 3 is equal to 2. And this is why I emphasize so much that these are the same thing. If you don't remember that that's an e right there, then you can't do this problem. Because you don't remember, we're not going to remember what to do here. So I can go e to the 2 is equal to x over 3. And remember that e to the 2 is just a number. It's 7 point bit, so I got my 7.389 is equal to x over 3. Well, then how do I get x by itself? It says x divided by 3, right? So I just do times 3. Times 3. Times 3. So 22.17. You know what? This isn't exactly x. I should use bacon. It's approximately x. Whatever, it doesn't really matter. Over here, x is approximately. The other thing that we can do in problems like this, and I know a few of you really like to do this, where instead of writing this mess, we can leave this as e squared times 3, or we write 3e squared. Because remember that this is a more accurate way to say it. This, I'm rounding to 2 decimal places. This, anybody can go to their calculator and go, oh, what is this? And they can look at the decimal for it. And they can see a much more accurate answer. Lee, was that a yawn? Yeah. That was weird. All right. I mean, sorry. I am professional. That didn't happen. All right. So we're going to skip number 13. Or again, you don't need to know how to do number 13, but I can bring the 2 inside, and I can say this is log of 4x squared is equal to log of 100. Drop the logs and get 4, which sounds bad, and divide by 4, get x squared is equal to 25, and then so that means that x is going to be plus or minus 5, but we can only have the positive one. Again, the only thing I would care about you getting in class is that we can combine those two. All right. Number 14. Given that the amount in an account earning compound interest is given by this formula. Oh, cool, I gave you the formula. Whoops. Determine the amount of money that you would have as a final balance if your money is invested at a rate of 5%, so that's 0.05. Compounded quarterly, that means 4 times a year over 25 years, and you start with 18 grand. That should just, if it feels too simple, you're not wrong. Why did I put the n there? Sorry, n is 4. That's what I get for trying to talk and write at the same time. So we put our starting amount where p was, we put our rate as a decimal, 4 times a year, 4 times a year. Those two numbers always has to be the same in this formula. So if I go in, see 18 grand, 1 plus 0.05 over 4 to the 4 times 25. I got $62,000, $341 and 28 cents. Remember, that decimal, I need to stop it there because that's money. Money doesn't have that next decimal place. Money stops there. I'm rich. All right. And our second to last question. Todd has bacteria continuously growing in his mouth at a rate of 12% each day because he has poor hygiene. No, I'm just kidding. All right. If there are 1,000 bacteria in his mouth right now, how many bacteria will be in his mouth in 2 weeks? So continuously growing and 12% each day. Move the decimal place twice. That's 0.12, right? So R is 0.12. This uses our A is equal to PERT formula, right? So we want to know how many. we start with 1,000, e to the r, and that says 2 weeks. Well, it says this is every day, so 2 weeks, that'd be 14 days then, right? So times 14. So if you start with 1,000 bacteria, it does this for 2 weeks. You got 5,000 bacteria. So I'd probably say you have this many, or maybe even round up. I mean, this depends on how you kind of philosophically want to answer it. I am not super worried about how you would answer that. And this very last question looks awful, but I could just rewrite this. I could say log base 49 of square root of 7 divided by 7 is equal to x. And I could just go in and I could use the log base, put the 49 there, square root of 7 divided by 7. There's my answer. Like, because we have these calculators, there's not a whole lot we can't do with these. That said, doing this by hand, it's a little tricky. Well, hey, I hope this helps for the quiz. I hope my class wasn't too loud, and have a great weekend. Or, whenever you're seeing this.